Alright guys, so in this problem we're going to take a look at linear functions when we only have a graph, when we're not actually given a lot of the general information about the problem. So let's start off with kind of analyzing what we've got. The graph below shows the increase in pressure measured in pounds per square inch as a scuba diver descends from a depth of 10 feet to 30 feet below water. Pressure is a result of the weight of the column of water above the diver, as well as the weight of the atmosphere of the earth above the water. And since pressure is going to be a linear function of depth, okay, we should recognize that we're looking for a y equals mx plus b equation. Okay. Now this problem is going to come into three parts. Okay, so the first is, what is the pressure of the diver at the water's surface? Okay. So basically a depth of 0 feet. We're going to interpret the value of m. Okay, that's going to be an important part for the context of this problem. Okay, so basically m is what is the slope. Okay, and then we're going to write the equation describing the linear relationship. So the full y equals mx plus b. So we can then use that to determine the pressure of the diver at 20 feet. Okay, so we're going to go for about that value. Okay, now there are a few things with this problem. Okay, the first is we're not necessarily going to solve it in order. Okay, it's going to be very hard to determine the pressure at 0 feet if we don't know the slope. Okay, because something that can be a little hard to see, okay, is that this measurement, okay, this value, is not actually on the line for 20 pounds per square inch. Okay, so even though visually we can get an idea of what's going on, we can't just say we have a fit relationship. Okay, so let's start with m. Okay, well, something to remember about m is our slope, and that's going to equal our rise over run. Okay, or as a lot of you may remember, kind of like y over x. Okay, now what happens here, okay, is when we look at this, okay, we may see a rise of 1 over a distance of 2. Okay, so we know that we're somewhere in the area of 1 over 2 slope, but we don't know that for sure. Okay, so what we can do is we can basically calculate the rise and run with the 2 points of data that we have. Okay, now if you don't remember it off the top of your head, basically y2 minus y1 gives us our slope over, or sorry, our rise over x2 minus x1. Okay, so here we can go ahead and start plugging in our numbers to help us calculate m. Okay, so 28.0 minus 19.1 over 30 minus 10. Now, calculator wise, okay, just go ahead and kind of simplify it down for us. We know that we have 28.0 minus 19.1 divided by 30 minus 10. Okay. And we could have gone ahead and kind of just narrowed it down, solved them individually, but basically we're going to find out that m equals 0.445. Okay, so m equals 0.445. Now the good news here is that means that we have part of our general equation. Okay, we can actually say at this point y equals that 0.445 times x plus b. Okay. Now, at a glance, we're missing 3 points of data, y, x, and b. But because of the chart, okay, the graph, we can go ahead and plug in those values and calculate for the unknown. Okay. So if we take that 28.0, put it in for our y, and then we put in 0.445x, okay, and in this case, x is the value of 30, so times 30, plus b, we now isolate for b. Okay. Now, recognize that these two are now paired together. It's multiplication. Okay. So if we subtract that from both sides, equals b. Okay. So we turn to the calculator. We take 28 minus 0.445 times 30, and we get 14.65 equals b. Okay. So here we can go ahead and start kind of calculating the whole formula. So, we've now basically kind of found what that b value is. And that's actually telling us what the pressure is, because the pressure at Earth's atmosphere, okay, is going to be that 14.58. Because if we take y equals 0.445x plus 14.65, okay, if we multiply that by 0, basically y at 0 is going to be equal to that 14.65, and in this case we'll want to remember our units, but that is basically the PSI, okay, or you may see it as the pounds over square inches. Okay. Okay. Either one of those units will work, but you just have to decide which one you're going to use and try and do so consistently. Which gets us to the final part of us now trying to calculate the pressure at 20 feet below water. Okay? So 0.445 times 20 feet plus 14.65, okay, and simply putting it into the calculator, 0.445 times 20 plus 14.65, and here pressure at 20 feet is going to be equal to 23.55 psi. So again, when you're working with these linear equations, recognize that you may not be solving the following problems in order, okay? But we can find the slope based on the information that was provided, okay, using the formulas that have kind of been associated with this. Once we have the slope, we were able to go ahead and take some of that known information and determine the regular Earth atmospheric pressure before we were able to go ahead and finalize our equation to calculate for what is the pressure at 20 feet. So hope this helps, and this is something that you will find used quite often when you're doing scientific experiments, when you're having to draw conclusions, and some other activities that you should expect out of engineering. So hope this helps.